Alright, this is Unit 16, Lesson 1. This is about inscribed angles. And basically we start off with the definitions and we're going to work our way through some applications of this. So first thing you need to do is, if you've got any idea that you might need to ask a question tomorrow, get yourself pencil and paper so you'll be ready to write your question down as we go along. And the quick thing to do is just to pause the video and write your question, and then have it ready for class tomorrow. Alright, so let's take a look at what we've got here. Definitions and such. Okay, the first thing we got is an inscribed angle. Okay, with an inscribed angle in a circle, this is an angle that has its vertex on the circle and whose sides contain chords of the circle. Okay, so this looks something like this in the diagram. If you look, it looks kind of like a Pac-Man thing, but actually what it is it's just an angle that has a vertex on one side and opens completely across the circle. So the arc that it makes here and the angle measure are related in a definite method, and we're going to talk about that. Okay. So the intercepted arc of an inscribed angle is the arc between the endpoints of the two chords that create the angle. So you've got this chord and this chord are creating this angle right here, and they intercept this arc. Sometimes people will tell you that it's being subtended, which is the same idea. Okay, the actual arc that they're talking about is this heavy information right here, the thick line. Okay, so the first theorem says if an angle is inscribed in a circle, and once again when they say inscribed, that means that the vertex of the angle is exactly on the circle, then its measure is half that of the intercepted arc. So if we know this arc, if we divide that by 2, it tells us the angle, or if we know this angle, if we multiply this by 2, it will tell us the arc. Alright, so if the measure of angle A is equal to 36 degrees, they want us to find the measure of arc BD and the measure of angle C. Okay, so what we have here is we got this situation going. We got a quadrilateral that's composed of two basic angles that are pointing together, looking something like an arrowhead. Okay, one of these is a central angle, which is the vertex is at C, which we know that this angle and the arc BD are going to be the same measure. But we also, what we have here is A, and the information they gave us was how big A was. So angle A is 36 degrees, and as we said, that means that arc BD that's intercepted by the two chords is going to be twice that. So the first thing we do is we find the measure of arc BD is 2 times the measure of angle A, which is equal to 2 times 36, which is 72 degrees. Okay, once again we said that angle C right here is actually a central angle, so the arc and the central angle have exactly the same measure. So since we know that the arc BD is 72 degrees, then we know that measure of angle C is also 72 degrees. Okay, this completes example 1. We're going to look at example 2 now. So example 2 says they want us to find the measure of angle A. This time they gave us the arc length, or the arc measure, which is 50 degrees. Okay, once again, since this is the arc measure, we divide this by 2 and that gives us the angle. So 1/2 times 50 gives us 25, and that's what the measure of angle A is. Okay, we have some more definitions and things. We have another theorem. It says if two inscribed angles of a circle intercept congruent arcs. Well, see if we can get it up here. There we go. Two inscribed angles of a circle intercept congruent arcs, then the angles are congruent. That's pretty much what you would expect, because if they're doing the same thing in a circle, you would expect them to be the same object. Okay. Conversely, this means going the other way. If you have two inscribed angles that are congruent, then their intercepted arcs are congruent. Okay, so let's see how they use this in example 3. They want us to find the measure of angle AED and measure of angle ABD. Okay, so let's take a look here. AED is this angle going across here that's on the right side of the circle, because it opens from E and goes out to D and to A, and it intercepts an arc that's 62 degrees. ABD is going this way to the left side of the circle, and if you notice, it has an angle that opens out that goes through A and through D that it also intercepts the same 62 degree arc. That means that angle ABD and angle AED are going to be exactly the same. Okay, so let's take a look and see how we get this. So since these are inscribed angles because the vertices are on the circle, then that means we take half of the arc measure, which is 1/2 of 62 gives 31 degrees for AED, and for ABD also is 31 degrees because they intercept the same arc. Since they intercept the same arc, that means that the angles are the same. So that's the exact results we just got. Okay? They could have found the same information if they had given us the fact that these two angles were 31 and asked us what the arc was. So that's the other way they can work this based on the theorem. Okay, another theorem says if an inscribed angle of a circle intercepts a semicircle, then the angle is a right angle. Okay, so if it's a semicircle, that means it's a diameter of the circle, and so that's going to cut it into two 180 degree arcs. So if it's an inscribed angle that intercepts that, then that means it's intercepting 180 degrees divided by 2 gives you 90. Okay? Then conversely, if an inscribed angle has a measure of 90 degrees, it has to intercept a diameter which creates a semicircle. Okay, example 4. If segment AB is a diameter of circle C, find the measure of angle D. Okay, so AB is this diameter going across. Notice it goes through the center of the circle, and it's a chord, which makes it a diameter. Then angle D is going to be 90 degrees. Okay, because it's half of the 180. Okay, this is an interesting thing to know. You could pick any point on one of the halves of the circle here, and as long as you draw the lines from here to the end points of the diameter, that will form a 90-degree angle. This is what the Indians in Central and South America used to create a lot of their building. They drew a circle in the ground, or a part of a circle, and used it to intercept a diameter, and that gave them a 90-degree angle. Okay, example 5 says if the segment AB has the same length as segment BD, and segment AD is a diameter of circle C, they want you to find the measure of angle D. Okay, so they're wanting us to find this little angle up here. B is up here, and we know that AB, which is this part right here, is the same as BD. And we know this is a diameter, so that means angle B has to be 90 degrees. So that leaves 90 degrees at angle A and angle D that have to be split in half. And the reason why is this. Because the measure of angle B is 90 degrees. That means that you have an isosceles triangle, so that measure of angle D has to equal the measure of angle A. And that comes from the fact that AB and BD are the same length, which force the two base angles, angle A and angle D, to be the same measure. Okay, so 2 times the measure of angle D plus 90 has to equal 180. So we subtract the 90 from both sides. So 2 times the measure of angle D is equal to 90. So the measure of angle D is equal to 90 over 2, which is equal to 45 degrees. Okay, that completes Unit 16, Lesson 1. Bring your questions to class tomorrow, and we'll be glad to answer them before we start any work. Thank you very much. Goodbye.